Hello, it's Dr. Mears, and today we are going to be dividing complex numbers. Let's first note when dividing by complex number, we need to multiply the numerator and denominator by the conjugate of the denominator. Complex conjugates come in the form of a plus bi, and its conjugate is a minus bi. Now, if we started off with the number a minus bi, the complex conjugate would be a plus bi. So these go either way. It just depends on what that denominator is showing you. So I'm going to tell you why we need to do it. We need to multiply by the complex conjugate after we do number one. So let's do number one. 2 divided by 3 plus 2i. So we're going to multiply both numerator and denominator by the complex conjugate of the denominator. So we have 3 plus 2i, so we have this, so we're going to do the conjugate, which is 3 minus 2i. What you do the denominator, you also do to the numerator, so 3 minus 2i, and now let's multiply. I'm first going to multiply the numerator. 2 times 3 is 6. 2 times negative 2i is negative 4i, and now I'm going to do the denominator. I'm going to do the work over here so that you can see the work done out. I'm hoping that you're going to be able to pick up a pattern by the time we do a couple of these. So we're going to do 3 times 3, which is 9. 3 times negative 2i, which is negative 6i. 3 is out. I use a double distributive, which you'll notice this is the second time I'm distributing. 2i times positive 3 is positive 6i. Positive 2i times negative 2i is a negative 4i squared. I times I is I squared. You'll notice that the 6i and the minus 6i, these cancel out. These should always be the same with opposite signs, and they should cancel out. I'm left with 9. Now this is minus 4i squared. I have a negative 4, and I squared gets changed to that negative 1. So this is really negative 4 times negative 1, which is going to give me a positive 4. So this whole thing changes to plus 4 because of this I squared. 9 plus 4 is 13, and I'm going to put that right here. We're not done yet because this is an entire fraction. I need to split these up so I have my real number because this is a real number and this is the imaginary unit. So I need to split this up. So what it's going to look like, it's going to be 6 over 13 minus, I just took that sign, 4i over 13. And the last thing I'm going to check, can I reduce this fraction? Is there a number I can divide both the numerator and denominator by? There is not. Can I reduce this fraction? No. So because my fractions have been reduced and it's now in the form a minus bi, which is fine. The real number just has to be first. I am good to go. So why do we have to multiply by the complex conjugate? Because in the denominator, we cannot have an I, and that's why we do it. It crosses the I out. We cannot have that imaginary number there, so it crosses that I out, so our denominator does not have a I in it. That's why we multiply by the complex conjugate. Let's try number 2. 2i divided by 4 minus 5i. We're going to multiply both the numerator and denominator by the complex conjugate of 4 minus 5i. So it's going to be 4 plus 5i, 4 plus 5i. We're going to multiply the numerator first. 2i times 4 is 8i. 2i times positive 5i is a 10i squared. I times I is I squared. Now I'm going to multiply the denominator. 4 minus 5i, 4 plus 5i. I'm going to get 16 plus 20i minus 20i minus 25i squared. It was just 4 times 4. 4 times positive 5i. 5i times negative 5i times 4, and negative 5i times a positive 5i gives us negative 25i squared. These should both be the same but opposite signs. They cross out. I'm left with 16. This is a negative 25 times negative 1, which is going to give me a positive 25, and that comes out to be 41. So we're going to put that here. I'm not done yet. I need to do a little bit of simplifying this. We have an I squared here, so we can definitely get rid of that. So that's going to be 8i minus 10, because remember that I squared is negative, so 10 times negative 1 is negative 10. over 41. I'm going to give myself a little bit more room here because I need to have this real number. The I term is second. So I'm going to do negative 10 plus 8i. I just can rearrange it. Negative 10 plus 8i over 41. And I'm going to split it up. Negative 10 over 41 plus 8i over 41. And I need to do a plus bi, which is good. Can I reduce any of my fractions here? No. So this is my final answer. Okay, next, number 3. We have 2 plus 3i divided by 4 minus 5i. Let's multiply both the numerator and denominator by, you got it, 4 plus 5i. So these should always be opposite signs. 4 plus 5i. And I'm going to put, notice I've been putting parentheses around my binomial here. It keeps it together and it tells me, okay, I have some either FOILing to do or double distributive, however you would like to do multiplication. So let's go. I'm going to do the numerator first. 2 plus 3i times 4 plus 5i. 2 times 4 is 8. And we get 10i, so that's done. That's 12i. And then that's positive 15i squared. And so we can combine like terms here. So I have 8 plus 22i. And we can change that because this is negative 1. So 15 times negative 1 is minus 15. And then I see that I have more like terms here. 8 minus 15 is going to give me negative 7. And I'm going to bring my 22i down. So now I can go and place that in my numerator, negative 7 plus 22i. And I can go on to multiply my denominator, 4 minus 5i, 4 plus 5i. This feels really familiar because, yep, we just did it here. So we got 41. I'm not going to do the multiplication out. We already did it once, so I'm just going to know that's 41. And if you didn't, then do the multiplication out. So I'm going to put 41 as my answer. My real number is first. Good. Let's split them up. Negative 7 over 41. Everybody gets a 41. 22i over 41. And let's see, can we reduce anything? We cannot reduce any fractions. Negative 741. We don't have any common number we can divide by, and 22 and 41. No common number. So we cannot go any further, and that's going to be our answer. Okay, let's take a look at a few more. Something a little bit different, like number 4, we have 7 divided by 4i. Now remember, we need to get the I out of the denominator. So the complex conjugate of bi, there's no a term. There's no real number in front. It's not like 2 plus 4i. It's just bi. So the complex conjugate of that is just negative bi. That's it. And you can go either way. So if we have a negative bi, the complex conjugate is positive bi. That's it. So here we have a positive 4i, so its complex conjugate that we're going to multiply is going to be negative 4i. Okay, 7 times negative 4i, negative 28i, 4i times negative 4i, negative 16i squared. And we are going to, let's keep the numerator the same for now, negative 28i. So always just hold on, don't reduce anything yet. Let's just take care of that I squared. So negative 16, remember this is a negative 1. Negative 16 times negative 1 is positive 16. And now we have to look, can we reduce? Yes, I can divide both 28 and 16 by 4. So I can reduce the fraction by 4. So negative 28 divided by 4 is negative 7i. 16 divided by 4 is 4. And my final reduced answer is negative 7i divided by 4. So notice I have no I in the denominator. That's the reason why we need to multiply by the conjugate. And we did that here. All right, number 5. 5 divided by negative 2i. And so we're going to multiply, and I'm just going to erase this here so we have just a little bit more room. Okay, after multiply, we have negative bi. So I'm going to multiply by a positive. So positive 2i, that's going to equal 5 times 2i is 10i. Negative 2i times positive is negative 4i squared. Now keep the 10i the same for now. Let's change this. This is really negative 1, so negative 4 times negative 1 is positive 4. So right now I have 10i over 4, and I can reduce this. Yep, I can divide both by 2, so I'm going to reduce the fraction. 10i divided by 2 is 5i, 4 divided by 2 is 2, and that's it. We don't have to split any of these because we just have that imaginary unit, and so we stop there. Number 6, there's the bell. 6 minus 8i divided by 6 minus 8i. This is one that you have to stop and notice. So this is a notice one. You have to notice that the numerator and denominator are the same. And when the numerator and denominator are the same, and you are dividing, the answer is going to be equal to 1, equals 1. That's because anytime you divide a number by itself, it's 1. 4 divided by 4, 1. 6 divided by 6, 1. 4i divided by 4i, 1. 6 minus 8i divided by 6 minus 8i, 1. So this is a notice one. You have to notice. But you also have to be careful because these signs, minus and minus, do have to be the same. So if you come across one like number 7, where we have 6 minus 8i and 6 plus 8i, these are not the same. One is minus and one is plus. So for this one, you are going to have to multiply by the complex conjugate of 6 minus 8i. And I think these are more intermediate type examples because you have to keep your signs straight. You have to keep your signs in order and organized. So you just have to be careful. So remember, it is always the complex conjugate of the denominator. So this is plus, that has to be minus. So now let's do some multiplication. First, let's just take care of that numerator. So 6 minus 8i times 6 minus 8i. And so 6 times 6 is 36 minus 48i minus 48i plus negative 8 times negative 8 plus 64i times I is I squared. Okay, let's combine some like terms. 36 minus 96i, negative 48i minus 48i gives you negative 96i's. This whole thing right here, because we have I squared, which is negative 1, is going to go from a positive 64 to minus 64. I will be able to combine those, so I have negative 28 minus 96i. Negative 28 minus 96i. I really do like doing my work over here. It gives me satisfaction to be able just to bring that over, and I have extra room to work with. Let's do the denominator now. I have 6 plus 8i, 6 minus 8i. 6 times 6, we have 36 minus 48i plus 48i, because remember, this is 6 minus 48 and then 6 plus 48i, and minus 64i squared. Positive times a negative gives you a negative. These two have to be the same but opposite signs, so we can cross them out. We have 36. This is going to change because that's negative 1 and we're multiplying negative 64 times negative 1 to positive 64. Combining that, we get 100. Here's satisfaction. Woo! Love that part. And so we bring that over to the denominator. So this was the numerator. That was the denominator's work. Numerator, denominator. And let's separate them. So I have negative 28 over 100 minus 96i over 100. I just made that the minus. And let's see what we can do to reduce. So I just first look at this first fraction, and I see that I can reduce both by 4. So I'm just going to divide by 4. So I get negative 7 over 25. And then I'm going to look here, and bring down my minus first. I'm going to look here and see what number, and I think again it is 4 divided by 4. And so 96 divided by 4 is going to be 22i over 25. I cannot reduce any further, so this is my answer. And that's how we divide complex numbers, making sure there's no I in the denominator. Hope it helps. Thank you.